Watch the complete playlist on the app Pions. Download the app now.
Two capacitors of capacitance 6 microfarad and 12 microfarad are connected in series. So let's draw a rough diagram. This is our 6 microfarad and the next one is 12 microfarad are connected in series with a battery. Let's draw a rough battery diagram here. The voltage across 6 microfarad is 2 volt. Compute the total battery voltage. Okay. So the two capacitors of capacitance 6 microfarad and 12 microfarad are connected in series with the battery. The voltage across the 6 microfarad capacitor is 2 volt. Compute the total battery voltage. Okay, great. So here if it is voltage V, okay, the charge which is coming out of this battery voltage, let's call it as Q. And if this is the Q, the charge across this will be same as the charge across this. Sir, why? Because they are in series. So for a series combination, charge doesn't change. Charge remains same. So whatever charge is flowing or charge is going accumulating across the plates of the first capacitor, the same charge is accumulated across the second capacitor if they are in series. Let's calculate the charge for the first capacitor. So Q is equals to CV. So what's the capacitance value? So 6 into 10 to the power minus 6. What's the voltage value? So 2 volt, just now given in the question. So 12 microcoulombs is our charge in the across the first capacitor. The same charge should be across the second capacitor. So if the same charge is there across the second capacitor, then voltage across the second capacitor will be equals to charge upon the second capacitance. Correct? So what's the charge? So charge here is 12 into 10 to the power minus 6. And what's the capacitance value? 12 micro. Wait, I did what? Yeah, 12 microfarad, no? So minus 6. So what is V2? 1 volt. If V2 is 1 volt and V1 is 2 volt, then what should be the battery voltage? The battery voltage should be 3 volts. Let's move to the next one. Great. Question number 11 says, three capacitors of equal capacitance when connected on series. So let's take it here, 1, 2, 3. Now since they have not given, let's call it as C, C, C. Sir, why you took it as C, 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 not C1, C2, C3? Equal capacitance as per the question. So three of equal capacitance are connected in series and their net capacitance is C1. Okay. So C equivalent in this case will be C1. When connected in parallel, let me write here parallel. Let's draw it to make it much more simple. And here C, C, C. The net capacitance is C2. What is the value of C1 is to C2? Clear? So first of all, if this is C, 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 then to find C equivalent, what you will do? In series, let me remind you once again, in series, it's opposite of resistors in, okay, series. So that is in case of resistors in parallel, which is 1 by C equivalent, that will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. And this will give you 1 by C plus 1 by C plus 1 by C, 3 by C. 1 apple plus 1 apple plus 1 apple. C equivalent in series is C1. So C1 will be equal to C by 3. Equation number 1. In case of parallel, C equivalent is equals to C1 plus C2 plus C3. So C2 is the C equivalent in case of parallel and that will be equal to 3C. Equation number 2. What is the ratio of C1 is to C2? So let's divide C1 divided by C2 as per the question. C by 3 divided by 3C. 1 by 9. So C1 is to C2 is nothing but 1 is to 9. That's your ratio.
Watch the complete playlist on the app Pions. Download the app now.